And on 3-5, where we're going to be talking about zeros of polynomial functions. All right, so the essential question is how do we find, or how are zeros of a polynomial function related to an equation and the graph? So we want to be able to model and solve problems using the zeros of polynomial functions. And the standard is to be able to identify zeros of polynomials when suitable factorizations are available, and use the zeros to construct a rough graph of the function defined by the polynomial. So the vocab we want to be able to describe is, well, we want to be able to know what a zero is, kind of going back to the beginning lessons, and more specifically, multiplicity of a zero. All right, so if we want to use zeros to graph a polynomial, so a zero of a polynomial function, remember, is the value for which the function is equal to 0. And the zero product property, that's one of the properties we mentioned way back. If you have a product equal to 0, then you want to set each factor equal to 0. So for example, if you had x plus 2 times x minus 1, and that is equal to 0, well, that's a product. We're multiplying those two together. So then we're going to set each of those factors equal to 0, and then we would solve. So that's the zero product property. So this is what we're going to be using in this lesson as well. To see how the graph of the function behaves on each interval, you want to look at the sign of each factor on each interval and the sign of the product. These are known as positive and negative intervals. So for example, with the same problem that I was just mentioning, here x would have to equal -2, here x would have to equal to 1. And then you're going to be looking at basically a number line with those numbers. You have 1, you have -2, and you're going to be looking at the signs on each side. So if I were to plug in like -3, for example, and I plug in -3 into here, well, -3 plus 2 is negative. -3 minus 1 is also negative. A negative times a negative is a positive, so this side will be positive. If I plug in like 0, for instance, well, in that case, if I do 0 plus 2, well, 0 plus 2 is positive. 0 minus 1 is negative. A positive times a negative is a negative. So this will be, this entire number line will be negative between -2 and 1. And if I were to plug in like 2, for instance, into x, well, then 2 plus 2 is positive. 2 minus 1 is positive. Positive times a positive is a positive. And that will give me my positive and negative intervals. All right, so we're going to be doing more with this. So with this example, find the zeros of the function f of x equals x times x minus 4 times x plus 3. And then we want to sketch the graph of the function. So we have our function x times x minus 4 times x plus 3, and we want to find the zeros, which means that we have to set this equal to 0. The 0 means x-intercept, and remember, x-intercept is when y or f of x is equal to 0. So we want to make f of x equal to 0, and f of x is that whole thing. So now this is a zero product property now, because we have 3 factors here. So here we have x equal to 0, we have x minus 4 equal to 0, and we have x plus 3 equal to 0. So then if we solve this one, well, this is just x equals 4. 4 minus 4 is 0. So we have 0, we have 4, and then this will be x equals -3. All right, so now that we have all of these zeros, these are my zeros here. So now that I have my zeros, I want to be able to sketch the graph of the function. So I'm going to do my positive / negative intervals. All right, so I'm going to do a number line. And I'm going to label my zeros on that number line. So I have 0, I have 4, and I have -3. It doesn't really matter as long as it's on the right. Positive is to the right, negative is to the left, all that stuff. So now we know that at -3 we have a 0, at 0 we have a 0, and at 4 we have a 0. So now we're going to test to the left and right of each of those values. So let's test to the left of -3. So right here, if we want to test to the left of -3, let's choose a value. Let's break this up. So we have x is less than -3. We have x is between -3 and 0. We have x is between 0 and 4. And we have x is greater than 4. So you see we have those 4 regions. So we're going to plug in a value into each of those regions. So let's plug in x is equal to -4, for example. So if we plug in -4 into the original, right? So we have x times x minus 4 times x plus 3. Let me rewrite it over here. So that's the original problem. So we're going to plug that into there. So we have -4 times -4 minus 4 times -4 plus 3. Well, this is going to be a negative, this is a negative, and this is a negative. A negative times a negative times a negative is a negative. So this part of the number line is negative. I'm going to do a different color for that. So that's negative right there. Okay, now let's test for the second interval between -3 and 0. So let's plug in a number like x equals -1. Now in that case, we get -1 times -1 minus 4 times -1 plus 3. Well, we have here a negative times a negative times a positive. Well, we know a negative times a negative is a positive, and then a positive times a positive becomes a positive. So we know that this part of the number line is positive. I'm going to go ahead and give myself a little bit more room with this part. All right. So for this part, we're going to plug in x equals 1. So we get 1 times 1 minus 4 times 1 plus 3. So we have a positive times a negative times a positive. Positive times a negative is a negative. A negative times a positive is a negative. So we have here a negative. And then the last one, we have x is greater than 4. So like 5, for instance, if we can plug in x equals 5. So we get 5 times 5 minus 4 times 5 plus 3. Well, that's positive 5, so that's positive. 5 minus 4 is positive. 5 plus 3 is positive. 3 positives multiplied together give you a positive. All right, so what does that mean? Well, the negative means that it's decreasing, or that it's not decreasing, that it's below the x-axis. Positive means above the x-axis. Okay, so this is below the x-axis, and then that's what negative means. Positive is above the x-axis. Okay, so now that we know those things, we can draw the graph. So we're going to draw a quick graph here. So let's do it here. All right, this graph doesn't have to be very detailed. It's just a sketch. So we know that our zeros are -3, 0, and 4. So that I know here it's going to be 0. At 0, it's going to be 0. And at 4, it's going to be 0. So I know that we have x-intercepts at each of those points. So I'm just going to put dots there, or points there. Now I know that from the number line, it's below the x-axis when it starts at -3. So I know that it's below. So I know that I'm starting somewhere down here maybe and then going up. Okay, so somewhere like that. And then I know that from -3 to 0, it's positive, so that means it's above the x-axis. So I know it's somewhere above the x-axis. I don't know how far up it is. I just know that it's above, all the way up until 0, right? It has to cross at some point. And then from 0 to 4, it's below the x-axis, so it's negative. I don't know how far negative it goes. I only know that it's negative. And then up until 4, and then after 4, it's above the x-axis again. So we have something that looks like that. And I don't know, again, I don't know what value that dips down to, and I don't know what value it goes up to. But I do know that this is the generic sketch. So that's my sketch of the function. You can get a lot of information just from these positive negative intervals to graph the function. Now another thing that I want to mention is that for this function, if you were to foil this, do that, and then do that, the degree of this, the degree of this polynomial is 3, because x times x is x squared, and then if I were to do x squared times x, that would give me x cubed. So the highest power is going to be 3, and it's a positive leading coefficient, right? It's a positive function because it's just positive x. So that means that it's odd and it's positive. And if you recall from the end behavior, odd positive is down and then up, which is exactly what we have here. If you look at the graph there, it's going down and then up. So this works out perfectly with our end behavior. It's down, then up, and then it has the graph. Something to keep in mind. All right, so go ahead and try it, factor each function, and then use the zeros to sketch its graph. We'll talk about it in a little bit. All right, so let's go ahead and talk about the problem. So we have to actually factor this. It's not factored for us. So let's look at the first one. So we want to, of course, set this equal to 0 to find the zeros. But we want to factor, right? So I noticed that there's an x here. I noticed that every single one of them has an x. I can pull out an x and I can pull out a 2. So I can factor out a 2x. So I'm going to factor out, the 2x here. And then I know that 2x times 2x squared is going to give me 2x cubed. I know that 2x times 2x is going to give me 4x squared. And then I know that 2x times -1 is going to give me -2x. So I'm kind of going backwards here in order to factor. All right, and then if I go ahead and distribute, I should get the original. All right, so now we know that this is equal to 0. And then we're going to use the zero product property, right? Well, first off, before we use the zero product property, let's see if we can factor this even more. Let's see if we can factor that. So this is going to be an AC method, it seems. So we have to review the AC method. So we have A, and then we have C. So A is 2, C is -1. So let's see if we can do the AC method and see if this works. So we have, let me do it over here on the side. So A, C equals 2 times -1, which is -2. So we need the factors of -2 that add up to +2. So are there any factors that multiply to -2 but add up to +2? I don't think that there would be any, because if you did -2 and 1, that would just give you -1. If you did +2 and -1, that would give you +1. So I don't think there's any way to do this. So there's no way to do this, right? So this must mean that we need to use So we might have to use a quadratic formula to be able to get this. All right, so we may have to do that. All right, so we will do that. Yeah, so we want to use the zeros. So let's go ahead and use a zero product property. So we know that 2x is equal to 0, and we know that this is equal to 0. But like we said, we can't factor it. So we may have to use quadratic formula. But let's look at the first one. So divide by 2 on both sides, and that will give you x is equal to 0. So that one's done. That one's pretty easy. Let's go ahead and use a quadratic formula on this one. Remember that the quadratic formula is negative b plus or minus square root b squared minus 4ac over 2a. So you have your a, you have your c, as we said earlier, and then you have your b. So we have here negative b plus or minus square root b squared minus 4 times a times c, a is 2, all over 2 times a. All right, we'll quickly run through this. So we have 2 squared is 4, 4 times 2 is 8, and negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8, and then 2 times 2 is 4. So we have negative 2 plus or minus square root of 12 over 4. And then we have to break apart the 12 into 3 and 4. This is prime. This is 2 and 2. We have a pair that we can pull out. So we have negative 2 plus or minus. We can pull out that pair, so 2. And then we have square root, bring down whatever's left over, goes on the inside. I know we went through that pretty quickly, but that's a review of how to simplify radicals. Negative 2, and then we're going to go ahead and let's go ahead and factor out a negative 2 from this. So if I pull out into 2, I get 2 times negative 1 plus or minus square root of 3 over 4. Now if you distribute this, you get the original. 2 times negative 1 is negative 2, and then 2 times square root of 3 is 2 square root of 3. And then the reason I did this is because this reduces. I can reduce this fraction, divide by 2, divide by 2. That's a fraction down for 2/4, and that gives you 1/2. So we have negative 1 plus or minus square root of 3. This becomes an invisible 1, which I don't need anymore. And then this becomes 2. And then I'm going to split up the fraction. So I just split up the fraction into 2 pieces. And that's my other set of 2 zeros. So we have 2 solutions here. Okay, so let me box up this whole thing. So we have two roots here. Roots are also known as zeros. And then we have 1 root here. So we have a total of 3 roots. Okay, I'm going to write the other root over here, x equals 0. So we have a total of 3 roots. And that makes sense because if you look at the problem, the highest power is 3, the degree is 3, so you should have at least 3 roots when you do this. So need 3 roots or zeros. All right, so now we can kind of use this to kind of sketch the graph of the function. I'm going to get these as a decimal though, because this is a little weird to kind of deal with this, right? So let's go ahead and convert this over into decimal format. So we have 0 is just going to be 0, but let's rewrite this. So this one, so we have 0.366 for one of them. and then negative 1.366 for the other. So now we have our zeros. Now we can do our number line. So we have 0, 0.366, negative 1.366. So let's go ahead and use the number line to help us out. So let's plug in a number like, let's plug in like negative 2, for example. Let's plug it into our original. So our not our original, but let's plug it into this one. I want to make sure that that's written that correctly. That's a minus 1. Okay, so if we plug in negative 2 into this, right? Well, we get 2 times negative 2, 2 times negative 2 squared, plus 2 times negative 2 minus 1. So this will be negative number. This is going to be 4. 4 times 2 is 8. 2 times negative 2 is negative 4 minus 1. This is going to be a positive number. A negative times a positive is a negative. Now let's plug in, like, for example, between negative 1.366 and 0, let's plug in like negative 1. Negative 1 is between those guys. So if we plug in negative 1, 2 times negative 1, 2 times negative 1 squared, plus 2 times negative 1 minus 1. Again, we're just plugging it into these guys. 2 times negative 1, well, that's negative. 2 times negative 1 squared, that's 2. This is minus 2. This is minus 1. Well, this is going to give me a negative. So negative times a negative is a positive. So I know this is going to be positive. Now let's plug in a number between 0 and 0.366, like 0.1. So if I do that, I get 2 times 0.1, 2 times 0.1 squared, plus 2 times 0.1 minus 1. This is going to be positive. 0.1 squared times 2 is 0.02. This is 0.2 minus 1. And that will give you a negative. So a positive times a negative is a negative. And then lastly, let's plug in, like, for example, 1 into the original. So we got 2 times 1, 2 times 1 squared, plus 2 times 1 minus 1. So this is going to be positive. This is 1 squared times 2 is 2. 2 plus 2 minus 1 is going to be positive. Positive times a positive is a positive. So now we have the intervals of increase and decrease. So now we can kind of make a quick sketch of this graph. So we have 0.366. That's actually, I don't want to label it like that. Let's label it as 1 here, 2, negative 1, negative 2, like that. And then, okay, so negative 1.366 is around here, and we know that that's a 0. We know that there's a 0 at 0. And we know there's a 0 at 0.366, which is, around here. So if we were to draw the function, then we know, okay, well, we know that to the left of negative 1.366 is down. It's below the x-axis, so we know it's below. Between negative 1.366 and 0, it's above. So it's above, so maybe like this. And then between 0 and 0.366, it's, negative, so it's below. And then between 0.366 and, well, actually, after 0.366, it's positive, so it's above. So probably something like that. And that's our basic sketch of that. So again, just a sketch. All right, now let's look at, and if you notice that it's positive odd, and it makes sense because it looks like a positive odd function, with the down and then the up pattern. All right, let's go ahead and quickly do B. So if we look at B, we want to set this equal to 0. Now this is a difference of squares, so you're going to actually be using your identities here. So you can use your identities to actually tackle this one. So remember the difference of squares: a squared minus b squared equals a minus b times a plus b. So that looks like a squared minus b squared. So in this case, we have x to the fourth. That can be written as x squared squared minus 9 squared. And now you know what your a is, and now you know what your b is. So in this case, a is x squared, and b is 9. So then we can plug that in here. So this equals x squared minus 9, x squared plus 9. There you go, that takes care of that. This is, now this here is another difference of squares. So you could do another difference of squares there. So let's look at that one real quick on the side. So this is going to be x squared, that's a squared, minus b squared. 3 squared is 9. So a is x and b is 3. So we can go ahead and rewrite this as a plus b, a minus b. It doesn't matter if you do minus here first or positive there, it doesn't really matter, as long as you have both of them. So now let's rewrite this again. So x minus 3, x plus 3. And then of course we have the x squared plus 9. All right, so now let's break that down again. So if we have this can be broken down into all of this. So let me rewrite it so it's nicer looking. So we have now f of x equals x minus 3, x plus 3, x squared plus 9. So that's the factored form, fully factored. And now this, we're going to set this equal to 0 in order to solve. So we're going to use the zero product property. So in this case, we have x minus 3 equals 0, x plus 3 equals 0, x squared plus 9 equals 0. So we have here x has to equal 3, x has to equal negative 3. Now this one we have to review. So this one, let's actually solve it out. So we have to do minus 9 on both sides. If we do that, we get x squared equals negative 9. Now remember, to get rid of the squared, you need to do a square root. So we're going to do the square root of both sides. But don't forget the plus or minus sign every time you do the square root of both sides. So now the square and the square root cancel, and you have x equals plus or minus square root of negative 9. And remember, you cannot take the square root of a negative number unless you have imaginary numbers. So this is going to be plus or minus. We know the square root of 9 is 3, but since it's negative, we're going to do I. So we have here 4 roots. We have a total of 4 roots, or zeros. And that makes sense because our degree here is 4. So that means we need 4 roots. So this is kind of important right here. Since our degree is 4, we need 4 roots. In this case, we have 2 imaginary and 2 real. So we have 2 imaginary roots, and we have 2 real roots. All right, so this means that the imaginary roots will not cross the x-axis because imaginary, it's not going to cross the x-axis because it's, imaginary. The real roots will cross the x-axis. So when we do the number line, we're going to ignore the 3i and negative 3i, and we're going to just focus on the 3 and negative 3. All right, so 3, negative 3. Now let's plug in a number to, let me rewrite the function. X minus 3, x plus 3, x squared plus 9. Okay, so let's plug in a number like negative 4. If we plug it in for x, we get, we get negative 4 minus 3. negative 4 plus 3, negative 4 squared plus 9. So this is going to be negative, this is going to be negative, this is going to be positive. Negative times a negative is a positive, and then a positive times a positive is a positive. So this is going to be positive. All right, now let's plug in a number like 0 here, between negative 3 and 3. So if I plug in 0 minus 3, 0 plus 3, 0 squared plus 9, 0 minus 3 is negative, 0 plus 3 is positive, 0 squared plus 9 is positive. A positive times a positive is a positive, a negative times a positive is a negative. And then lastly, if I plug in like 4, I get 4 minus 3, 4 plus 3, again, excuse the writing here, and 4 squared plus 9. So we got a positive here, we have a positive here, and a positive here. 3 positives make a positive. All right, so now we can do a quick sketch of this graph. Using those those two zeros there, negative 3 and 3. So we know that it's positive to the left of negative 3. So to the left of negative 3, it's positive. So that means it's above. So it's probably something like this, you know, where it starts out above. Let me try to draw that. And then between negative 3 and 3, it's going to be, you know, it's going to be negative, so it's going to be below. Now, I don't know how it behaves below. I just know that it's below. And then all the way up to 3, it stops being below. And then after 3, it's going to be positive. Okay, so there's my function. Now, again, I don't know how far down it goes. I just know that based off of what we have here, this is the best guess of how it looks like. So now if we look at this graph, I went ahead and went on Desmos and I typed in x to the 4th minus 81. So it turns out, you know, if you look at the graph, it starts going up, you know, on the left side, it goes all the way down to negative 80. Of course, you know, we can find out that it crosses at negative 80 if we plug in like 0 into the function. But it turns out it goes all the way down to negative 81. But remember, the purpose of this was not to be able to find those specific points. It was just to be able to get a general sketch of the graph. So it goes all the way down, and then it goes crosses, and of course it's going to cross at x equals 3, which is what we found. And on the left side, it crosses at x equals negative 3, which is what we also found. So it kind of looks like a parabola, which makes sense because it's even and it's positive. So if you go back to the original, even and positive means that, so it's even positive, which means it's going up and up on each side, which makes sense. All right, so what about multiplicities and how can they affect the graph? So the multiplicity of a 0 is the number of times its related factor appears in the factored form of the polynomial. So here are the rules that you want to keep in account. You want to know that if the multiplicity of a 0 is odd, the function crosses the x-axis. If the multiplicity is even, the function has a turning point at the x-axis. So what do I mean by that? So let's look at an example. So let's say I had x minus 1 squared times x plus 1 cubed times x plus 2. So let's look at the multiplicities here. If we were to find the zeros, well, what makes that equal to 0? Well, it's going to be x equals 1, right? What makes this equal to 0? When x is negative 1. Negative 1 plus 1 is 0. What makes this equal to 0? Negative 2. So we have here 3 distinct zeros. However, this is x is equal to 1 multiplicity 2. How do I know it's multiplicity 2? Because of I have two of them. So if I have two of that same 0, that's called multiplicity 2. Now here I have 3 of that other 0, so my multiplicity is going to be 3. So I have x equals -1 multiplicity 3. And then the other one, the last one, this is an invisible 1 here, right? So I have x equals -2 multiplicity 1. So really I have 2 plus 3 plus 1. I really have a total of 6 zeros. It's just that some of them are copies, right? So that's what multiplicity is all about. And if you notice, the highest power here, the degree here is 6. So it makes sense that the degree matches up with the number of zeros. So this is how multiplicity, is found. And then, well, what does that mean? Well, that means that if the multiplicity is even, that means that it's going to turn at that point. So since here, so if we were to write it out, x equals 1, we have a turning point. At x equals -1 and x equals -2, we have where it crosses. How do we know it crosses? Because the multiplicities are odd. 3 is odd and 1 is odd. So that's how you determine whether it crosses or turns. This will help you out with the graph. So let's do more examples. So for each function, determine the zeros of each function and their multiplicities. Find the positive, negative intervals, and then describe the behavior of the graph at each of its zeros, then sketch. So let's do the zeros first. This is already factored, so let's set it equal to 0. So we're going to use the ZPP, zero product property. So we have x minus 1 equals 0, x plus 2 equals 0. So what makes this 0 when x is 1? And what makes this 0 when x is -2? So we have here our zeros. Now, so this is going to be x equals -1 multiplicity 1. This is going to be x equals -2 multiplicity 1 as well. How do I know it's 1? Well, because there's an invisible 1 power there and 1 power there. So that's it. That's why it's multiplicity 1 by default unless there's powers there. All right, so determine the zeros and their multiplicities. Now B, find the positive, negative intervals. So now this is where we're going to do, the number line. So we have 1, we have -2, and now we're going to, let's see about plugging in. So let's plug in a number like, for instance, let's plug in like -3. So let's plug in like -3. If we plug in -3 into the function, into here, what we have here, -3 minus 1, -3 plus 2. This is going to be negative. This is going to be negative. Two negatives make a positive. So this is going to be positive if we plug in -3. So I'm going to make this positive. Let's plug in like 0 for between -2 and 1. So if I do that, I get 0 minus 1, 0 plus 2. 0 minus 1 is negative. 0 plus 2 is positive. This is going to give me a negative. So I have here a negative. So let me write negative here. Let me erase that 0. And then let's plug in 2 to the right of 1. So 2 minus 1, 2 plus 2. So we have positive times a positive, which is a positive. All right, so now we know where increases, decreases. We know that, let's do the behavior. So we know that at -2, it's going to cross, and at 1, it's going to cross. How do we know it's going to cross? Because the multiplicities are odd. If the multiplicity is odd, then it crosses. So now we can draw a quick sketch. We have -2. So we have -1, -2. We have 1. Again, just a quick sketch. So if we plug in, we know that it's going to cross at -2 and cross at 1. We know that it's positive to the left of -2, so it's probably going up like that. And then we know it's negative between -2 and 1, so it's probably going to be, decreasing, has a turning point at some point. And then it's positive after 1, so we know it's, above. So it looks something like that. And if you look at this, we have, the degree of this is going to be 2, because if you were to FOIL, you're going to get an x squared. So this makes sense that it looks like a parabola. So that's our sketch. Now let's look at number 2. So let's do our zeros real quick. So we have x minus 1 equals 0, x plus 2 equals 0. So we have x equals 1. Now this 1 is going to be multiplicity 2 because of that 2 there. This is going to be x equals -2 multiplicity 1 because there's an invisible 1 there. All right, so now we got, this is even, so that means it's gonna, there's gonna be a turning point. This is odd, so it's gonna cross. So now let's do our number line. Let's do -2, let's do 1. So let's plug in a number like -3 here into the original. So we have x, I'm going to write the original, x minus 1 squared times x plus 2. So we have -3 minus 1 squared, -3 plus 2. -3 minus 1 squared, that's positive. -3 plus 2 is negative. Positive times a negative is a negative. Let's plug in like 0. 0 minus 1 squared, 0 plus 2. We have a positive times a positive, which is a positive. I know I'm kind of going quickly through this, but this, it's really not hard to find out on the calculator that it'll give you positive. So now let's do like 2 minus 1 squared, 2 plus 2. It's going to be positive. Positive and positive. So it's going to be positive there. All right, so we have, I'm going to erase this because I need to write something down. This is going to be a turning point. This is going to be where it crosses. So now let's draw a quick sketch. In this case, if you were to graph this, you're going to have -3 or -2. There's a 0 there. There's a 0 at 1. To the left of -2, it's decreasing. So, it's below the x-axis, not decreasing. It's below. And it crosses at -2, so we know it's going to cross. And then it's going to go into positive territory above, up until 1. From -2 to 1, it's positive. And then it says that there's a turning point at 1. So that means it's going to turn. And then it's going to remain positive after 1. So there's our graph. So this is our turning point right there. So that's what a turning point looks like. All right, so number 3, I'm going to quickly go through this. So we have x is equal to 1 multiplicity 3. This is x is equal to -2 multiplicity 1. So it's going to cross. It's going to cross. So we have -2, we have 1. So let's plug in like -3 into the original. So if we plug in like -3, we have -3 minus 1 cubed, -3 plus 2. It's going to be negative times a negative is a positive. Let's plug in like 0 here. 0 minus 1 cubed, 0 plus 2. We got a negative times a positive, which is a negative. And then lastly, let's plug in like 2. 2 minus 1 cubed, 2 plus 2. We have a positive times a positive, which is a positive. And then we said here it, well, both of these, they cross. So now let's draw the quick sketch. So it's above to the left of negative 2. It crosses negative 2. It's negative until it gets to 1. So it's negative until it gets to 1. It crosses 1, and then it goes positive. So there's our approximate sketch. All right, and then last one. So this is going to be x is equal to 1 multiplicity 4, because of that 4 there. This is going to be x equals negative 2 multiplicity 1. So here it's going to turn. Here it's going to cross. Oh, also I'll make a note here that technically if it's odd and it's a 3, it crosses, but it does some kind of a wiggle pattern. I forgot to let you know that. So when for the previous problem, if it's 3, it does cross, but it does kind of like a wiggle pattern. So it kind of looks like, so it crosses, but then it kind of does this. I forgot to let you know that that does kind of like a wiggle. Not that it really changes that much, but it looks very different from a normal crossing. And so just so that you know, it does cross, but it does sort of like a wiggle. Okay, so going back to 4, now we have our zeros. So we have 1, we have negative 2. Let's plug in negative 3 into this guy. So negative 3 minus 1 to the 4th, negative 3 plus 2. This is going to be positive times a negative, which is a negative. Just because I'm running out of room, I'm going to just rewrite this. So let's plug in like 0. 0 minus 1 to the 4th, 0 plus 2. This is going to be positive times a positive, which is a positive. And then now let's plug in like 3. Or like 2, let's do 2. 2 minus 1 to the 4th, 2 plus 2. So we have positive times a positive, which is a positive. All right, so now we can kind of graph this. All right, so to the left of negative 2, it's negative, so it's down. It crosses here, and it turns here. So it crosses the negative 2, goes positive up until 1, and then it turns at 1 and goes back up. So there's our graph. All right, so the behavior, just that multiplicity changes the behavior a whole bunch. If you look at these graphs, all the different multiplicities are different, right? This is 3, 4, 1, and 2. So it's the same kind of function, but different multiplicities. And it changes the behavior dramatically, as you can see. All right, go ahead and try it. Describe the behavior of the graph at each of its zeros. So you don't have to graph, you just have to describe the behavior. Does it turn? Does it cross? All right, so let's go ahead and do this real quick. So if you want to describe the behavior, we're going to use the zero product property. So this is going to equal 0. This is going to equal negative 4. Negative 4 plus 4 is 0. This is going to equal 1. So it's going to be 0 multiplicity 1, negative 4 multiplicity 1, and 1 multiplicity 4, because of the 4. All right, so here it's gonna turn, here it's gonna cross, and here it's gonna cross. And that's it. That's all they were looking for. All right, part B. So we have here x squared plus 9. Okay, well, let's solve this. Subtract 9 on both sides. X squared equals -9. Take the square root. Don't forget the plus or minus. So let me rewrite this. And then this is going to be plus or minus 3i. That's imaginary. So we have two answers here. We have x equals 3i, x equals -3i. And each of those are multiplicity 1. But it doesn't really matter because, you know, it doesn't cross. So if it's imaginary, it doesn't even cross. It doesn't cross, it doesn't turn, it doesn't do anything. It doesn't even touch, right? So you don't really have to worry about multiplicities when it comes to imaginaries. You just need to, you just say, okay, well, it doesn't cross, it's imaginary. Okay, so now for this one, x is equal to 1, multiplicity 5. X is equal to -2, multiplicity 2. All right, so here it crosses, here it turns. All right, that's all you had to do is determine, you know, whether it crosses, whether it turns, and that stuff. Of course, you can graph it and you can, you know, sketch the graph, but we know the main behavior. All right, so now we need to find the real and complex zeros for the polynomial function shown in the graph. So how do we go about finding the real and complex zeros? All right, so here, if we look at the graph, we know it crosses at 2. So we have a 0 at x equals 2. Because we have a 0 at x equals 2, we know that x minus 2 is a factor. How do we know that? Well, like for example, let me just give you a quick example. Like if we had x minus 2, x plus 1. Well, we know that x minus 2 is equal to 0, which means x is equal to 2. So if 2 is a 0, then that means we know that x minus 2 is a factor. So we're just kind of going backwards here. So if we know that if x equals 2, that means x minus 2 is a factor. If we knew that the 0 was x equals -1, that would imply that x plus 1 is a factor. So that's how you can kind of go backwards between those two. So we know that x minus 2 is a factor, so we can technically figure out where the other factors are by dividing. So find other factors by division. And I know you guys are not going to like the long division, but this is where it comes into play. If we want to find out the rest of these factors, we got to do division. So we're going to do this divided by x minus 2. And then we embark on this division process. So x times x squared is x cubed. X squared times 2 is -2x squared. Subtract. I'm going to go straight forward because we already went over this in the previous lesson. Cancel. 2 negatives make it positive, so we got 1 plus 2 is 3x squared, bring down the minus 3x. Now we got to fill in the blank. So we know that x times 3x is going to give me 3x squared. So that's going to give me 3x squared. That's going to give me -6x. Subtract. Cancels. Double negative is a positive. We get 3x. Bring down the -6. And then we fill in the blank again. So what times x is 3x? That's going to be 3 times x is 3x. And then 3 times -2 is -6. We got a remainder of 0. So now we got our quotient. So now we know that x cubed plus x squared minus 3x minus 6 is equal to whatever we divided by times our quotient, x squared plus 3x plus 3. So now we factored it. So it's factored. So now they want us to find the other zeros, right? Find the real and complex zeros. So now we're going to use the ZPP. So we know x minus 2 equals 0, x squared plus 3x plus 3 equals 0. So this is going to be x equals 2. That's one of our zeros. This one we have to use quadratic formula. So I'm going to go ahead and use the quadratic formula real quick. So negative b plus or minus b squared minus 4 times a times c over 2 times a. 3 squared is 9. 4 times 3 is 12. And it looks like I'm going to get imaginary. So this is going to be imaginary. So I'm going to write this as square root of 3i because of that negative 3. And then I'm going to split the 2 into both fractions. And that's my other two zeros. So x is equal to that. So we have our real and complex zeros. All right, go ahead and try the following problems, and then we'll go over it in just a little bit. Pause the video. All right, so let's go over the first one. What are all the real and complex zeros for the polynomial shown in the graph? So if you look at the graph, it looks like one of the zeros is x is equal to 3, which means that x minus 3 is a factor. All right, so that means that we need to be able to divide this polynomial by x minus 3. So this is going to be divided by x minus 3. All right, so what times x is 2x cubed? That would be 2x squared. And then 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. Subtract. We got a double negative, so that's a positive here. Negative 8 plus 6 is negative 2x squared. Bring down the 9x. Fill in the blank. So what times x is negative 2x squared? That would be negative 2x. So we have negative 2x squared, and we have negative or positive 6x. Subtract. Cancels. 9 minus 6 is 3x. Bring down the negative 9. So blank, so what times x is going to give you 3x? That would be a positive 3. And then 3 times negative 3 is negative 9. Subtract. So you get a remainder of 0. So then if we rewrite this in the product form, we get 2x cubed minus 8x squared plus 9x minus 9 equals x minus 3 times 2x squared minus 2x plus 3. And that's the product form, and there's no remainder, right? The remainder is 0. So we don't really need that. So that's how it looks like factored. All right, and so now what we're going to do is we're going to set this equal to 0 and use the 0 product property. So we have x minus 3 equals 0, and we have all of this equals 0. So if we do this side, we have x equals 3. And then this side, we need to use the quadratic formula. So let's use the quadratic formula. So we got x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Again, just using that formula. So we have two negatives as a positive. Negative 2 squared is 4. 4 times 2 is 8. 8 times 3 is 24. All over 4. So now we have 2 plus or minus square root of negative 20 over 4. This is negative, so that means we have an imaginary. So we have 2 plus or minus square root of 20i over 4. We're going to have to simplify the square root of 20 real quick, or the 20. So that breaks into 2 times 10. That breaks into 2 times 5. So we have a pair of 2's that we can pull out. So we're going to pull that out of the radical. And then what's left over is the 5. So 5 is left over on the inside. And then we're going to factor out a 2. So 2 times 1 is 2. 2 times 1 is 2 as well. So that's how I got 1 square root of 5. If I distribute that, I get the original. There's an I here over 4. And then this is a fraction that I need to reduce. I need to reduce that by dividing by 2, top and bottom. And that will give me 1 plus or minus square root of 5i over 2. Then I'm just going to split it into 1 over 2 and square root of 5i over 2. Alright, so we have that as our zeros and that as our zeros. So our zeros are x equals 3, x equals 1/2 plus square root of 5 over 2i, and x equals 1/2 minus square root of 5 over 2i. So those are our 3 zeros. Alright, so now let's look at this one. Looks like we have two places where it crosses. So we have a 0 at x equals 2. We have another 0 at x equals negative 2. And then we're going to, so if x equals 2 is one of our zeros, this means that x minus 2 is a factor. And if x equals negative 2 is a 0, then this means that x plus 2 is a factor. Notice that the signs are swapped there, right? Alright, so x plus 2 and x minus 2 is a factor. So that means that what we're going to do is we're going to divide this by x minus 2 and x plus 2. So we're going to divide by both of them. So we're going to do two divisions here. So let's do this divided by x minus 2. Let's do that first. So we're missing some zeros here, right? So we're missing a 3 power. So I'm going to include a third power here. And we're missing a x to the 1 power. So I'm going to include that as well. All right, so what times x is x to the 4th? That would be x to the 3rd. And then x to the 3rd times negative 2 is negative 2x to the 3rd. Subtract. This is a double negative, so it becomes a plus. This becomes 2x cubed. Bring down the minus 3x squared. So we know that, so what times x is 2x cubed? That would be 2x squared. And then 2x squared times negative 2 is negative 4x squared. Subtract. Double negative becomes a positive here. This becomes 1x squared. Bring down the 0x. So now what times x is x squared? That would be x, positive x. and then x times negative 2 is negative 2x. We're subtracting, cancel, so we got a double negative here, so that's a positive, so this is 2x. Bring down the minus 4. So what times x is going to give me 2x? That would be 2, positive 2. And then 2 times negative 2 is negative 4. So this works out perfectly, 0 remainder, as it should. All right, so far this is equal to, when we divide those two, we get x cubed plus 2x squared plus x plus 2. So we know what we get. So now we're going to take this and we're going to divide it by x plus 2 now. So now let's take that divided by x plus 2, since that's also a factor, right? So let's go ahead and do that division. Since we already divided by x minus 2, let's go ahead and divide by x plus 2. All right, so x plus 2 on the outside. Yeah, x cubed plus 2x squared plus 2x plus 2. A lot of division, but if you can get through this quickly if you know what you're doing. So we have what times x is x cubed. That would be x squared. And then x squared times 2 is 2x squared. Subtract those. This is actually going to give me 0. Bring down the 2x. So what times x is 2x? That would be 2. So we have 2 times x is 2x. Let's go ahead and bring down this plus 2 as well. And then 2 times 2 is 4. So subtract those. So 2 minus 4 is negative 2. All right, so I made a mistake here. That's not a 2, that's actually a 1. So that should be a 2 instead of a 1. So this will be a 1 right here. So that changes our answer slightly. So that means that this has to be 1, because 1 times x is x. And then 1 times 2 is 2. So there you go. Now that would give us a remainder of 0. So I apologize for that. So now we are able to factor it perfectly. So we got x plus 2 and x squared plus 1. So now, if we put everything together, right, we're going to use these 3 pieces together, that, and this. If we put it together, that means that x to the 4th minus 3x squared minus 4 is equal to x minus 2 times x plus 2 times x squared plus 1 with no remainder. So there you go, we factored it. So now we can set it equal to 0 and solve, use the ZPP. So we have x minus 2 equals 0, x plus 2 equals 0, x squared plus 1 equals 0. Of course, we already knew that these were 2 and negative 2. That's how we got them to begin with. But this one we need to actually solve by subtracting 1 on both sides and then taking the square root. Don't forget the plus or minus. And the square root of negative 1 is I. So this is going to be plus or minus I. So all of our zeros turn out to be 2, negative 2, I, and negative I. And that's our guy. All right, so now we're going to do one more example, and we're going to talk about solving polynomial equations. So polynomial equations are just equations, with, polynomials on each side. So in order to solve a polynomial equation, you want to make one side equal to 0, and then see about if you can factor or use quadratic formula or any other techniques, okay? So we want to set one side equal to 0. That's our first tip. So we're going to move everything to one side. Oops. We're going to move every single thing to one side. So in order to do that, let me rewrite the equation. Let's move everything to the right-hand side. So I'm going to move this 2x cubed over by subtracting it. I'm going to move this 5x squared over by subtracting it. And I'm going to move this 3x over by adding it so that it cancels. So now I got 0 on one side. 3 minus 2 is 1x cubed. So I'm going to erase that 1. It's invisible. 8 minus 5 is 3. And then we got a plus 3x. That can't combine with the 1, so I'm just going to write the 3x down there. And then I'm going to bring the 1 down. So that'd be plus 1. All right, at this point we have a cubic polynomial, third order. How do we solve this guy? Well, I would suggest see if you could figure out a number that you can plug in that will give you 0. So this is kind of like where we kind of guess, almost like guessing what the answer is. So let's guess if, let's say x is equal to 1. Try making it equal to 1 or negative 1 to see if you get 0. And plug it in. So if we do 1 cubed, 1 squared, and then plug in 3 times 1 and 1, that's not going to give us 0, right? So that's going to give us 1 plus 3 is 4, 4 plus 3 is 7, so this is going to give us 8. So x minus 1 is not a good guess, right? And then we'll just see about negative 1, okay? So sometimes, negative 1 works. You're going to be given scenarios where it's actually nice numbers. It's not going to be like crazy numbers, for this. So let's try negative 1. Negative 1 to the third. 3 times negative 1 squared. 3 times negative 1 plus 1. And then negative 1 to the third is negative 1. Negative 1 squared is 1. 1 times 3 is 3. 3 times negative 1 is 3, or negative 3. And lo and behold, this actually gives you 0. So that works. So x equals negative 1 is a 0. And so that's one of our solutions. So we have x equals negative 1 as one of our solutions. How do we find the rest of the solutions? Well, since we know x equals negative 1 is a solution, this means that x plus 1 is a factor. So kind of like what we did before, we're going to do some long division here in order to get the other factors. So that way we can set them equal to 0 and solve. So let's go ahead and get the other factors. Our original is cubed, squared. Okay, so we have x cubed, 3x squared, 3x, and 1. So we're going to take this and we're going to try dividing it by x plus 1. All right, so what times x is x cubed? That would be x squared. And then x squared times 1 is x squared. Subtract. Cancels. There's an invisible 1 there. 3 minus 1 is 2. Bring down the 3x. So now we need what times x is 2x squared. And that would be positive 2x. And then 2x times 1 is 2x. Subtract. 3 minus 2 is 1, so we got 1x. Bring down the 1. So what times x is going to give you 1x? That would be just 1. And then 1 times 1 is 1. Subtract, so you get 0 as your remainder. So if we were to rewrite this, we have x cubed plus 3x squared plus 3x plus 1 is equal to x plus 1 times our quotient. All right, with a remainder of 0. All right, so now we're going to set this equal to 0 and use the ZPP. So we have x plus 1 equals 0. We have x squared plus 2x plus 1 equals 0. We can actually factor this a little bit more. For this one, we're going to factor that one a little bit more in a second. This one, we're going to subtract 1 on both sides, so we get x is negative 1. So that's one of our zeros. This one we can actually factor. You can use quadratic formula, or you could just factor. So we know that we need the factors of 1 to add up to 2, and that would be 1 and 1. So this would be x plus 1 times x plus 1, which is x plus 1 squared, by the way. So this is x plus 1 squared. So that means that if we set that equal to 0, that means x has to be negative 1. So again, we have a bunch of negative 1s here, right? So if we were to, since this factored, let's rewrite that. Let's take this guy and let's rewrite it into x plus 1, and then this became x plus 1 squared, right? The second part. So this is really x plus 1 cubed if you rewrite it. So this is actually x plus 1 cubed, funny enough. So we only got 1, 0, negative 1 out of this. However, we have a multiplicity of 3. Which means that it crosses, and more specifically, it wiggles. Not that we're answering that in this question, but it's something that you want to consider when you make the graph. But in any case, we have negative 1 as our 0. All right, go ahead and try the following problems, and then we'll go over in just a second. Pause the video. All right, guys, so let's go ahead and work on the problems. So let's look at this one. So for this polynomial equation, we're going to, again, move everything to one side. So let's move everything to the left side here. Actually, let's move everything to the, let's do the right side. Let's move everything over to the right side. So let's move that over by subtracting it. Let's move this over by adding it to this side. And then we'll subtract the 6 on both sides. That way everything on the left side goes away. So now we have, notice that x cubes cancel out here, so that's nice. So now we have 5x squared. Negative 2 plus 7 is positive 5x. Negative 24 minus 6 is negative 30. So now we're going to factor out a 5. So if you pull out a 5, well, 5 times 1 is 5, 5 times 1 is 5, and then 5 times 6 is 30. So that's how I got that. And then now we're going to use the zero product property. Actually, let's see if we could factor this. So this can be factored. So let's do negative 6 on top and positive 1 on the bottom. So factors that multiply to negative 6 but add up to 1. That would be 3 and negative 2. So this can be factored. 5, x plus 3, x minus 2, using those numbers that we just got. So now let's use the zero product property. So we're going to say x plus 3 equals 0, x minus 2 equals 0. So we get x equals negative 3, x equals 2. So those are our two solutions to that polynomial equation. Now let's look at part B. So again, we're going to move everything over to one side. Let's move everything over to the left side this time. So let's get rid of this so that we can add it over. And let's add the 2x over to both sides. So now this right side goes away. So we have x to the 4th plus x cubed plus 2x squared plus 2x. So now this one you can actually factor by grouping here. So we're going to put 2 parentheses here, and then we're going to pull from each group. So from this first parentheses, I can pull out an x cubed. So x cubed times x is x to the 4th. X cubed times 1 is x cubed. plus, now for the second parentheses, I can pull out a 2 and an x. So 2x times x is 2x squared. 2x times 1 is 2x. And now, remember that if these match, this means that you can make one of those your factor, and your other factor is going to be whatever's in front of each group. And this is equal to 0. We're almost done here. We can actually pull out an x from this. So let's pull out an x. So if we do that, we get x times x squared is x cubed. And then x times 2 is going to be 2x. And then times x plus 1 equals 0. So now we completely factored this. We can solve it. Let's use the ZPP, zero product property. So we have x equals 0. We have x squared plus 2 equals 0. And we have x plus 1 equals 0. So x equals 0 is automatically one of our answers. This one we got to actually solve by subtracting on 2 on both sides. Then we do the square root, remembering to do the plus or minus square root. So this is going to be plus or minus square root of 2. Since we took a square root of a negative number, it's going to be an I. And then for this one, subtract 1 on both sides, so x equals negative 1. So we got 4 answers here, right? We got x equals 0, square root of 2i, negative square root of 2i, and negative 1. All right, so yes, these problems can be quite difficult and time-consuming, but I hope you got something out of this lesson. I know this was a relatively long lesson. We're probably going to split this out over, a couple days to kind of review. This is the lesson. This is the final lesson that we're going to go over for this. This is where it ties in all the different concepts that we've discussed up to now. All right, hope you learned something from this video, and I'll see you in the next one.